Hey everyone. Today we're going to be working on section 6.4, which are basic graphs of the sine and cosine function. So we will be going through all of the general characteristics of these two functions. This is the first section from quiz number 2. The second section is those graphs of tangent, cotangent, cosecant, and secant. And then the third section, we're going to take the sine and cosine functions and shift them as well. So let's get started. Now, when I'm talking about graphs of sine and cosine, there are a couple of pieces of information that are helpful to get us going. So both of these functions are periodic and their period is 2 pi. So if you think about the unit circle, the x and y coordinates recycle every 2 pi units. So the functions themselves are periodic that way. So each of them has a domain of negative infinity to infinity. You can put any x value in, but the range is restricted between -1 and 1 inclusive. So we'll go through that on the unit circle. The graph of f of x is equal to sine x is an odd function, which means it's symmetric about the origin. If a function is symmetric about the origin, if you flip it 180 degrees over, it still looks the same. The cosine function is symmetric about the y-axis. So if you were to fold that function on the y-axis, if it is not shifted, then it is symmetric about y. So that's called an even function. So we're going to start today with the graph of sine. So as you remember from the previous section of content, if you're looking at the unit circle, then the sine function is our y coordinate on the unit circle. So here, hold on. It's a basic graph of the unit circle. So if I'm looking at the y coordinate, remember that this is 0, this is pi over 2, this is pi, and 3 pi over 2. The coordinates themselves, at this point we have the point 1, 0. So at 0 and at 2 pi and 4 pi and so on, our sine function of that angle is equal to 0. So at x is equal to 0, sine of x is also equal to 0. So this is review from the previous section. Now if we get to pi over 2, the coordinate of that point is at 0, 1, so we know that the sine of pi over 2 is equal to 1. Make it over to pi, the coordinate of that point is -1 and 0, so the sine of pi is back at 0. 3 pi over 2, coordinate is 0, -1, so the sine of 3 pi over 2 is equal to -1. Moving back to 2 pi, sine of 2 pi is coterminal with 0, so we get 0 again. Okay, if I were to plot that on a graph, on the x-axis, sine is at the 0, 0 mark. So this coordinate is at 0, 0. If we move to pi over 2, at pi over 2, sine is equal to 1. Sine of pi over 2 is 1, and I have a point here. Sine of pi is back equal to 0, so we have a point here. Sine of 3 pi over 2 is -1, so I have a point. Sine of 2 pi is equal to 0 again, so it starts over. Now, both sine and cosine are wave functions. So these are considered the points, the 4 points of the primary period. We've actually put in 5, but the 5th one is the first point from the next period. So these are the 4 points of the primary period, and from here we just try to make it a curve. So I don't want you to plot 60 points in order to get this curve. I want you to plot those 4 points of the primary period and then plot it in as curvy as possible from there. So essentially, if it doesn't look like triangles, you're in good shape. And this is the basic sine function graph. Now when you look at the cosine graph, cosine we're going to plot the same way using the unit circle, But with cosine, we're talking about the x coordinate. So if I were to put those coordinates back on the unit circle, at 0 and pi over 2, we're still at 1, 0. Here we're at 0, 1, negative 1, 0, and 0, negative 1. So for cosine, the cosine of 0 is equal to 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is back to 0. And then cosine of 2 pi, we're back at 1. So plotting in the cosine, where our sine function started at the origin, cosine at 0 is already at 1. And then at pi over 2, we go to 0. At pi, we're at negative 1. 3 pi over 2, we're back at 0. And at 2 pi, we start the second cycle of cosine. So plotting that in, again, like sine, in as little straight lines as possible, and we have something that looks like this. So these are the two basic functions, and we can transform these in a number of ways. These are what's called sinusoidal functions, and the sinusoidal functions are sine and cosine. The basic general form of it, we've been working with the function y is equal to just plain old sine of x, or y is equal to cosine of x. But they can get more complicated than that. So the general form of a sinusoidal function is a times sine of omega, this is omega, the Greek letter, x minus phi, also a Greek letter. There's debate among mathematicians whether that's pronounced phi or phi, but we're going to call it phi, and plus b. So same with cosine, a times cosine of omega x minus phi plus b. Now, if you are working to graph the functions, which we will be going into detail for in section 6.6, a controls the amplitude of the function. Amplitude is about the height. So our amplitude is equal to the absolute value of a. Absolute value because it's really a distance. Omega controls the period. Period is how fast the function recycles. So the general period is 2 pi, but if you have a number in front of your x, an omega component, that changes the period. So the period is generally represented with a t, and it's calculated with 2 pi over omega, whatever omega is in your equation. Phi over omega is what shifts the graph left and right. So these are called a phase shift in sinusoidal functions, and it shifts it left if you have a positive sign, and it shifts it right based on this sign if it's negative. So this is a horizontal shift, and we will go through those in detail in 6.6. And then b, the number that we add to the end, shifts the graph vertically. So if b is positive, we shift the graph up. If b is negative, then the graph shifts down. You may remember transformations from either college algebra or pre-calc. These work in the same general way. So if I want to figure out what the terms of a, omega, phi, and b are in these sinusoidal functions, I can look at the positioning of the numbers. So remember that y is equal to a times cosine of omega x minus phi plus b. So here a is equal to 2. Omega would be equal to 3. Phi is equal to pi, and b here is equal to -4. Watch your signs on these, because if you have a negative here, remember that shifts it down. But a negative inside here is part of the formula. So if you have a negative there, then you're shifting to the right. If I'm looking at this function, y is equal to, I'm going to move the 2 over to the back so that it's in the traditional form. So -4 sine of 3x plus 9 plus 2. So looking at our a terms, a here is -4. Note the negative. If we're asking for the amplitude is the absolute value. So we have 4. Be careful what you're being asked for on the questions. A here would be -4, but the amplitude is positive. Our omega, again, is 3. Our phi term here is -9. The formula itself has a positive, so if we have a positive or a negative, so if we have a positive in here, it means the value is negative. And b is equal to 2. All right, let's talk about what those actually mean. So when we're dealing with the period of a sinusoidal function, this is a graphic of sine of x. So the regular sine of x is this blue line here. So it recycles, it has a full period in 2 pi. Now you can either lengthen or shorten that period based on omega. So if I were to have an omega of 2, that means that I'm shortening the period and the sine function is occurring twice as frequently. So looking at that period here, I'm recycling in pi units instead. So remember that t, our period, is equal to 2 pi divided by omega. Now in this one, omega is 1 because I don't have a number in front of the x, so it's an understood 1. So 2 pi divided by 1 gives me just plain old 2 pi. So that's our line in blue there. When we move to the sine of 2x, the period is equal to 2 pi divided by 2, meaning that it recycles every pi units. So in that 2 pi, we get 2 full cycles of the sine function. If I'm looking at the third one, it says that f of x is sine of x over 2. Well, I can rewrite that as sine of 1/2 times x. So my omega is really 1/2. T is equal to 2 pi divided by 1/2. When you divide by a fraction, flip it and multiply. So 2 pi times 2 over 1 gives me 4 pi. So if I'm looking at the green line here, you notice that it's only halfway through the cycle at 2 pi. So to get all the way through the bottom half, I'd have to go all the way out to 4 pi here. Now as far as amplitude is that stretching factor on the front. It controls the height of your function. So the regular sine function has an understood 1, and you can see the graph here. We have 1 sine x. We don't write the 1 because it's understood, but the regular graph of sine x goes to a height of 1 and -1. Now if I change that amplitude to 2, then what happens is that we go to 2 in the y direction, both positive and negative. Change the amplitude to 3 and you get 3, and so on. Change it to 4 and so on. So every time you put a multiple in the front of your function, you're stretching it vertically and you achieve higher and lower values. The amplitude itself is this absolute value of a. If you were to have a negative, then what it does is flip it across the x-axis upside down. So if I were to graph, let's say in pink, f of x is equal to negative sine of x, then I'm still starting in the origin. We're still the same amplitude as the red function, except it's the mirror image over the x-axis. So we'll put in a couple of periods here, but the mirror image over the axis, that negative sign of x. Now the midline is the center of the graph. So if you have a function that's shifted up or down based on your b term, that midline shifts and it's like a faux x-axis. We will go over some with midline shifts in section 6.6. For today, we're going to graph some basic functions that have a shift in amplitude, potentially a reflection over the x-axis, and an adjustment in the period. So let's first graph the function f of x is equal to -4 sine of x using the key points in the primary period. Now a period on this function is equal to 2 pi over omega, and you see that omega is 1, so our period here is equal to 2 pi. Now in every period you have 4 primary points. You can find those by taking your period, 2 pi, and dividing by 4. So this means that every pi over 2 we have a point in the primary period. Now you'll see how that changes when we change the period, but pi over 2 are going to be our points in our primary period. Now we have an amplitude of 4. So instead of going to 1 and -1, we're going to be going to 4 and -4. We also have a negative value in front, so this is going to be flipped over the axis. So we're still starting at 0, 0. We're going to place a point in the primary period every pi over 2. Just to recall, the basic sine function is the one that goes like this. So that picture should be in your head right when you get started. What does sine look like? Sine looks like this one. Cosine is the one that starts at 1, goes down and back up. So we're starting in the sine function like this, except I'm negative, so I'm flipping it upside down. So at pi over 2, the next point in our primary period, I'm at 4 in the negative direction because we're upside down. At pi, we're back at 0. At 3 pi over 2, we're up at 4. At 2 pi, we're back at 0. And then we're cycling through the second cycle. So we have 2 periods here in the graph, or almost 2 periods. And I'm going to just ballpark it in. And working on that graph. And it looks something like this. Looking at the next one, we have -3 sine of 2x. So you notice that my graph is not numbered, and sometimes you have to number the graph yourself. So if we're looking at the period here, our basic one is 2 pi over omega. So 2 pi over 2 this time gives me pi for the period. So our primary points are going to be that value divided by 4. So every pi over 4 we're putting primary points this time. Our amplitude is equal to 3. So I'm going to number our axis to 3 and -3. We're also flipped upside down, but remember that our basic sine function is the one that looks like this. Okay, so our point at 0, we have to get some values on our x-axis. If you're numbering for trig graphs, it's the same as for regular graphs. So you have positives going one way, negatives going the other, but they should be the same hash marks. Now I want to number in every pi over 4 units this time. So my first one, pi over 4. Then we have 2 pi over 4, which is pi over 2. Then 3 pi over 4. And then pi, 4 pi over 4. So that's one period of the function. Now if I want to go a period in the negative direction too, you can. So -pi over 4, -pi over 2, negative 3 pi over 4, and negative pi. All right, putting in our function points. So our 4 points of our primary period, we're starting at 0. We're flipped upside down, so we're going to negative 3, going back to 0, positive 3, back to 0. Now if I continue in the negative direction, this is the way I'm working. It's like in reverse. So here is my second part. Now I'm going to pen this in. And working the other way. And looks something like this. All right, let's do another one. This one is 2 cosine pi over 2x. So I picked this one, or made this one, just because we do not always have a period that has to do with pi's. So you think of radians and units of pi, but that's not necessarily true. It doesn't have to be. So if I'm looking at this cosine function, remember the basic graph of cosine starts high, goes low, goes back high. So this is the basic cosine shape, and we're basing it on that. Our period here, 2 pi over omega, where our omega is pi over 2. So I'm taking a whole number and dividing by a fraction, so I'm going to flip it over. And we end up canceling the pi, and we get a period of 4. So our marks in our primary period are that whatever our period is divided by 4. So 4 divided by 4 gives me 1 for our marks in our primary period. Now, our amplitude is equal to 2. So I'm going to number that. As far as the marks that I'm making across the x-axis, I'm going to use units of 1. So 1, 2, 3, and 4, and negative 1, negative 2, negative 3, and negative 4. All right, primary period. Cosine starts at its high point, goes through the origin, or 0, goes to the bottom, 0, there. Bringing in a second period on the negative side. If you notice, my curves are not perfect. If you were drawing these in by hand, I wouldn't expect yours to be perfect either, but I do want to see them some sort of curve. So if you're drawing them in and you are working on something, I want to make sure you're not just drawing in, something that looks like this. So try and do some sort of curve as you draw them in, but I do not expect it to look perfect. If you have questions on this part, let me know. I'm happy to meet, and good luck on this section. Thanks.